Okay, so in this lesson we're going to use the fact, a proven fact, that the limit as x approaches 0 sine x over x equals 1 to prove another limit. All right, we're going to be using the squeeze theorem to do that. So these are two things that we might be uncomfortable with. Actually, in this proof, I won't be using the squeeze theorem at all. We used the squeeze theorem to prove this one, and this one we're just going to use this fact. Okay, so so in a lot of ways this proof is a little bit easier than the other proof because we're not having to use the squeeze theorem, but let's check this thing out. All right, so what we'll do is we'll start off with this limit as x approaches 0, cosine x minus 1 all over x. All right, now that should look pretty familiar because we know something about Pythagorean identities, and we know that if we have a difference on top like that, well, I guess what we should do first, I guess, is to substitute in 0, right? And when you substitute in 0, you would get cosine 0 minus 1 over 0. And that's 1 minus 1 over 0. And we get this indeterminate form, right? Now, what do we typically do when we get an indeterminate form? Well, we look to factor, to rationalize, to, what was that other one? Simplify a complex fraction, right? And eventually we cancel something out, all right? So what I'm telling you is that this is our thing that we're going to cancel out, all right? So let's go ahead and get to a point to where we're working on this thing. So once we've got indeterminate form, what we're going to do is rewrite the whole problem, and then we need to multiply by something on the top. Now, what would you advise? What would you say to multiply on the top? Remember that a squared minus b squared equals a minus b times a plus b. And that's our factoring, difference to square factoring thing. You remember that? So let's use this backwards. So we have a minus b written right here. So what would I multiply by? Exactly, cosine x plus 1. And if I multiply by cosine x plus 1 on top, I'd have to do it on the denominator as well. All right, so that's that. Now don't go canceling that out because you need that. Okay, so now let's look at what we have on top. Well, if I distribute that, the difference of squares formula tells me that I would just get cosine squared x minus 1. So the limit as x approaches 0 is going to be cosine squared, of cosine squared x minus 1 over x times cosine x plus 1. Okay, so what about that cosine squared x minus 1? Yeah, sine squared. I remember the Pythagorean identity that sine squared theta plus cosine squared theta equals 1. So if I subtract sine squared, let me see, subtract cosine squared, what am I saying? Help me out.
I don't think it would work. You get sine squared by itself. You get negative sine squared.
Okay, so negative sine squared. So okay, so let's do this. Let's just finish this up. Sine squared equals 1 minus cosine squared theta. All right, so that's not exactly it. So if I took a negative out, be negative sine squared theta equals cosine squared theta minus 1. Is that true? Okay. Well, let's do that then. Limit as x approaches 0 of negative sine squared x all over x times cosine x plus 1. I'm going to simplify that a bit just to help myself out some. Instead of writing this as sine squared x, I'm going to write it as sine x times sine x. And those are equivalent, right? All right. So in continuing our work, we get limit as x approaches 0 of sine x over x times negative sine x over cosine x plus 1. Okay, so I just wrote them out as two different factors rather than keeping them under one fraction bar. I just wrote it as two fraction bars with a multiplication symbol between them. Now we know that the limit of a product is the product of two limits. So the first factor that we have is the limit as x approaches 0 sine x over x. The second factor that we have is the limit as x approaches 0 negative sine x over cosine plus 1. Sorry, cosine x plus 1. Now, this says use the fact that this equals 1. All right? In our calculus class, we're not going to be doing too many proofs, or I shouldn't say we're not going to do a lot of them. They're not going to be tested on the AP exam. However, doing some of these will convince you of the answer. So that's why we're doing some of these. So this one you'll have to memorize. This one's just 1, okay? And you'll have to use that fact often. So this is 1 times, and now actually what we're going to do on this one is actually just substitute in the 0. Put that 0 in. So negative sine 0 over cosine 0 plus 1. Now what is sine at 0? Yep, sine at 0 is just 0. So this gives me 1 times 0 over 2, which is 1 times 0, which is 0. And that's what we were looking for the whole time, right? We just proved, so you might say something like, therefore, the limit as x approaches 0 of cosine x minus 1 over x equals 0. And this would be your last statement of a proof, right? And actually, if you were super formal about it, you would have some kind of like shaded box at the bottom to let everybody know that you're done with the proof. Okay? So, did my best to show you the proof of why this one equals 0. So, in our real life, here's what we're going to need to remember. We're just going to remember that this one equals 0 and that this one equals 1. All right? So in future problems, when I give you problems, these might show up in the middle of the problem. And then you'll have to figure out how to use that theorem.